Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. So expect this to take a long time for you if you're going to do your puzzle on your own, or for me because this very hard puzzles usually take a while. Today's puzzle is called Grouping All But Two, and it's by Snepix. Here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We need to divide all cells in the grid except for row 9, column 7, and row 9, column 9, the two gray cells, into groups of orthogonally connected cells. What is an orthogonally connected? And that means it's a region in essence. Every group contains exactly one cell with a white circle. And the digit in a circle cell, n, indicates the number of cells in that group. And all cells in a group have the same parity as n. Row 9, column 7, and row 9, column 9 are not in any of the groups, and maybe any digit, but are still affected by normal Sudoku rules. Okay, so what is an orthogonally connected region? It just means a region where you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because you can go from this cell to this cell just by going through edges while staying within the region. Also, this is a valid region too, orthogonally connected region. What you cannot have, though, is something along the lines of this as a region. Because these two cells, even though they can get to each other by just going through edges while staying within the region, cannot get to any of the other cells in the region just by going through edges while staying within the region. They have to go through a corner, or they have to go through an edge and exit the region, neither of which are allowed. And again, all cells in a group have the same parity. So, for example, if this were a region here, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the size of the region. So this would be 9. All the other cells in this region would have to be the same parity as 9. um, As an example, okay, so they have given an example. A circle cell contains a 4 in a group of 4 orthogonally connected cells that are all even. So then this would be 4. And then you would have 2, 6, 8 as possibilities here. And this could be 4 here, right? Note, adjacent cells with the same parity could still be part of different groups. The parity restriction solely affects cells within the same group. So adjacent cells with the same parity could still be part of different groups. So you could have another even cell here, but it's part of a different group, right? So that is possible. Into groups of orthogonally connected cells. Okay. What else do we have? Digits separated by a white dot are consecutive, and not all dots are given. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 to make sure that those digits are consecutive, because there's a white dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these are the digits 1 through 9 in these circles. Since every region has to have a circle in it, this adds up to 45. And the first 5 rows in the first 5 rows have 45 cells exactly. And every cell must be part of a group except for these 2 cells here. So these 45 cells must be part of a group with one of these circles. So therefore, these circles cannot extend further down here. So these are definitely going to be boundaries here for the groups. Also, the groups have to be the same parity. So that means these are guaranteed to be different groups here. Guaranteed. Because these have to be different parities to be consecutive with each other, right? You can't have 2 odd digits next to each other. You can't have 2 even digits next to each other and still be consecutive, right? Well, we know all of these groups here are different. All these cells are different as groups. But we don't know which one is which. We also know all of these groups. All of these cells are different groups. Same here. Same here. Same here. Um. Hmm. Okay. So this has to form a group somewhere. These are part of the same group. So we're going to make that light. These are part of the same group. We're going to make that dark. This is going to have to be size 5 at least for both of these. Hmm. These, so these add up to 34. Okay. Oh, this is part of the same group as that. So we know these are the same group. Make that yellow, I guess. These could all be just 1. So these total add up to 34, which is 34 times 9, 36 minus 2 cells. Oh, we also have boundary here and boundary here. Okay. Right, we have 2, 4, 6, 8 even cells, which must be, that adds up to 20, which is exactly how many even cells we have in 5 rows. Even digits, I should say, in 5 rows. Um. So these add up to 34. How many odds and even cells do we have? We have 4 times 4, which is 16 even cells at most. We have, so 16 at most, so we have 14 to 16 even cells accounted for. Odd cells, we have 5 times 4, which is 20. So 18 to 20 odd cells. Okay. These 6 cells must be exactly the same as these 6 cells here. Okay, does that tell us anything? I'm not sure. Hmm. These are obviously, well, just leave them as gray. Hmm. These two are the same parity. I guess it could go. Can this ever be 6 or 8? I don't. I think the answer to this is no, right? So these 6 cells must match these 6 cells there. So we could have 3 that are the same as 3 of those. Hmm. Hmm. Must add up to 34. Um. hmm. I don't think this can ever be 6 or 8. If we try, well, we could do that. Yeah, maybe it could be 6 or 8. Hmm. So how many digits can be here from 5 through 9? 1 from 5, obviously. 2 from 6, possibly. 3 from 7. Or 4 from 8. Okay. 5 from 9. So that's 15 possibility Possibilities. Um. Hmm. Interesting. So this could actually be even. It can only be even if it goes this way. And sorry, it could be 6 or 8 if only if it goes this way, which would force that to be 1. This would have to be 3, 5, 7, or 9 there. Hmm. Um. Hmm. These can't be part of the same region. That would be 7 apart. Then 8, 9, which doesn't reach a circle. So these are part of other regions. Interesting. Um, hmm. Blah, 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 blah. How does this group together? Hmm. Yeah, the real restriction I feel are the even sums, the even parity. You can't have four, you can't have more than 4 in a row or a column. Okay, so what does that mean then? This cannot block, obviously, block the light. But the thing is, it could be. All of these. Oh. That's interesting. All the evens here. These have to be all the same parity, guaranteed. Because everything that's even has to obviously go up to connect to their group. Everything that's not, essentially everything that's not 1 has to go up to connect to their group. And all the evens must connect with an even cell. That's 4 evens accounted for in row 4, which means all the rest are all odd. Interesting. So these are all the same parity as each other. Guaranteed. Huh. So this is the same pair. Well, we don't know. Okay, well, we're going to mark these just as different colors. These are all the same parity, guaranteed. And then for row 3, everything but 2 and 1 are extending up. Oh, that's not true. We could have 3 go sideways, potentially, into the 1 thing. 4, 6, and 8 all have to extend up. So we have 3 evens guaranteed there. Oh. All the evens in row 1 cannot be part of the 4 group or the 2 group. They must be part of the 6 group and the 8 group. So 6, 8 can have all 4 there potentially. So, but 6 can only have 2 at most. So 6 has to have is 2 at most. 8 has to have 2 at least in row 1, be part of its group. So these are all the same parity. You can't have 3 even. You can't have 3 odds and 3 evens in the same box, because then that would give you 6 of its parity, which obviously you have 5 odds and 4 evens, so that's not possible. So each set has to be, one set is guaranteed to have 2 evens in it, because you can't have, obviously, all 3 of the boxes have only 1 even in it. There has to be a 4th even somewhere. So one of them's guaranteed to have a set of 4 evens in the box, which means one of these sets of 3 have to be the same parity. Well, that's interesting. The other one's going to have a split of 1 so the other 2 boxes have to have a split of 2 evens and 1 odd. Interesting. Fascinating. So the odds could be next to each other. It's not a guarantee. Okay. Can these ever be odd? Sorry, can these ever be even? I think the answer to that, it could be, couldn't it? You could have, say, 6 here, and then the other one would be 3 and then go down, right? And then do something funky like that. So you could have an even. They both cannot be even, though, there. One of them has to be odd, at least. Because the reasoning is, if they're both even, you have to have 2 other evens accounted for in a group of evens. But the problem is, if they're both even, how do you connect that and still not block the other cells? You can't, right? This would be, if this is even, this is even, these would both be odd. One of these would have to connect. You can one of them would have to connect to 6, one would have to connect to 8, because they can't be part of the same set, of the same group. So the problem is the 8 would have to connect to 2 more at least, and that would block the odd cells from ever connecting to another group, which is not allowed. So, hmm. We know these are different parities. We don't know which ones though. Okay. In row 3, we know the 2 stops as a group. So that means the other even digit must be next to a 4 or 6, the 4, 6, or 8 group. Because it had all the evens have to be in the even groups. So one of them is in 4, 6, or 8. That means 4 could potentially stop there. Um, hmm. Um, what else do we have? That's row 3. Hmm. Do we have any information on which has to be the box which has 3 odds in row 6? Hmm. I don't think so. Um, hmm. And we know that it has to be a set. One of these boxes is a set of 2 of evens, but the other ones have to have at least one even in these groups. Otherwise, that would be too. There again, you'd have 3 odds in a group, which would give us 6 odds in a box, which is not allowed. Um. Okay. Hmm. Um. Hmm. Coloring doesn't help here. None of these can connect to 8. Because if any of these connect to 8, the problem is the 6 can only give 2 in row 1, and 8 would have to connect to something here in row 1, which is not... Again, 8 has to have 2, at least, in row 1. So neither of these can connect to row 8, or the group of size 8. So the edges could be 5, 6, 7, or 9. Don't know which. Can it be 6? 1, 2, 3, 4, 5, 6. It can't be there. If it's 6, it cannot be 6 down here because that's 5 evens in a column, which is not allowed. We have 4 at most. And if we tried going this way, it would... Oh. I think the ends have to be odds. So if we try to have... Okay, if we try to have an even in one of these rows, again, 8 doesn't work because 8 needs at least 2 digits in row 1 accounted for in the group. And going this way would block this cell from having a group. 6 doesn't work because it would have to go like this, and that would force these to be 2, which would mean these are both even, which means they would have 5 evens in a column, which is not allowed. And again, cannot go here because of 5 evens in the same column. So these are guaranteed then to be odd. Interesting. Which means these are both even. And these are different sets. Interesting. That's fascinating. So that we have these are part of 5, 7, or 9 as a group. We have the same problem with 9. Because is it? 7 could go 1, 2, 5, 6, 7. Okay, 7 could be 3. So never 9. 9 does not 5 has to be one of these two. Because if 5 is not one of these two, then you can't go here to go here. Because that would block these even cells from being part of a group. Same with this. So these are the only ones available for those odds there. But 7 could be here, right? You could have 1, 2, 3, 4, 5, 6, 7, and then all the odds are accounted for in row 1. So one of these has to be 5, which is just straight down. So one of these is all 4 evens. One of these is all 4 evens. Guaranteed. So we know 5 has to be one of these two. Okay. And it's going to be 5 just straight down here. That means one of these sets are going to be all even. That's interesting. Hmm. 1, 2, 3, 4, 5, 6, 7. You cannot do that. So you can't have 1, 2, 3, 4. You can't go that way. What about evens this way? One of these is taken up by one. One of these has to be even. Okay. So, how are these sets going to work? One of them has to go blue. Can just be a singleton, I guess. And then the other one would be 3 and then down. Or you could have 2 on each side. What happens if you have 2 on each side? You have 2 here. That one of them would have to go straight down. And so then you'd have red here. This has to be part of this set here. So if it goes 2 down, 2 and then down, this has to be part of red. That would force this all to be 5. Because this is greater than 5. This would be blue. I don't think that works. Right. So you can't have... Yeah, you can't have 4 here. So this does not work. You cannot have 2 and 2 then. Because if you have 2 and 2, one of them has to go straight down as a 6. The other one would be 8. Then could go other places. But the problem is, this doesn't have a group yet, so it has to connect to this group. This is a set of 5. Therefore, since this is connecting to this group, it's odd. This has to be even then. But how do we form an even set with a number? We have 6 already here. This can only be 4, but then that blocks this from having a group. So one of them is going to have to go down. So it's going to have to go blue, blue, and then the other one has to have 3, essentially. So then we have to have red going here. Okay. This is 1, 2, 3. So this has to be part of 8, which means this is part of 6. So we have blue going that way in one of them. It's either going to be here or here. That means this is red. We have 8 here. So this is adding up to 8 as a set. This would be 6. So this is either 3, 5, or 1, 7 in that case. And then we have 6. So one of the side ones is going to have a blue here or a blue here with the reds being there. And this is either going to be 7. Yeah, we have 7 and we have either 3 and 5 or it's 1 and 7 here. We have 1, 2, 3 as part of 8. This could be just 7 that way. 4, 5, 6, 7, 8. So that's possible. So we have 7 there. This would have to be then 5 and 3. This would be 6. This would be 8. So this is possible. So then this would have to be 9. And then we have 1, 2, and 4 here. This would be part of that. So it has to connect here, because otherwise if it doesn't, then that's not going to be part of the group. Well, I think that, what does that mean? That means this has to be red no matter, I think these have to be red no matter what. Can we ever have a blue here? I don't think so, right? 2, maybe. Let's try having a blue on one of the edges. So this is blue. That means this has to be 5 here. So this is 5. These are not part of that group. This has to be red going, connecting. It could connect this way. Then you'd have blue and blue. Can you have blue going this way? The answer is no. So this would have to be 6 this way, if that's the case. So this would be 6. This would be red. This would have to be red and be 3. These would all be blue. We're trying to have a blue here. Hmm. We have to have 3 reds here, all in a row. This is all blue. That would force all of these to be red. Oh, okay, well that's helpful. Okay, so one thing we know. This cannot be the 6. If this is 6, then all of these are red, but these have to be different sets because they're consecutive. So this can never be 6 here. It has to be 6 here. So this is 6 here. This forms a set of all red parity. And this is 1, 7, or it's 3, 5. We're not sure which. So again, 5 has to be one of these two. This can't be 5 then, which means this can't be 3. This has to be 6. This is already 4 evens in this box, so this is red here. This must be 3 reds in a row here. This must be 3 blues in a row there. 8 cannot go to here, because that would be too long. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8 could be any of these cells here. This is all blue, so this cannot be blue. We have 4 blues in column 3, which means the rest cannot be blue. Therefore, it must be red. These are 5 reds in column 1, so the rest must be blue. This is red. That forces this to be blue here. Hmm. So this is obviously border here as a group. This could be 2 or 4, possibly. Red has to go down here. One of these is blue. These are the same parity. So this cannot be 8. This has to be 2, 4, or 6 here. We don't know what parity this is. One of these is even. At least. Can you really have 8 go here? Hmm. Oh. Okay. We have 5 odds in box 4. That means the remaining digit is even. So either these are both red, and this is a 1, or this is 2, 4, or 6 as an even. We don't know which. Actually, we do. We have 4 evens in column 2, so this cannot be even. This is odd. Therefore, this is odd, so this has to be a 1. That's size 1 as a group. This must be, well, we don't know. We know that's a separate group. This is size 6. So this is a 6 here as a group. This is even, this is odd. We don't know how large this is. 3, 5, 7, 9. This can't be 1, so this can't be 7. So this must be part of the group, and it could be 3 or it could be all 7 here. We don't know. That means 1 and 6 have to be in one of those 4 cell or 6 cells. Can this be 2 evens here? So say this was even, then one of these is even, therefore that would make this odd. The rest of this would have to be odd. We'd have odd there. I guess you could connect that way. 1, 2, 3, 4, 5, 6, 7, 8. But then one of these would be even. We'd have even there. And that... How would that work? So, assuming this is even, one of these is even, we have an even there. That's 4 evens in the row. So then this would be odd, odd. One of these, therefore this would be odd. One of these is even, so therefore that would force this to be even. This has to connect that way, so that's odd, which would force that to be even. Huh. So the problem is this would have to be even here as a set, but the problem is you would have to have another even here, which is too many evens in a box. There would be 6 evens in this box here. Because if you have an even here, it's 4, or it can't even connect to here, right? It would be 6, and then this would be 1, 1, which is not possible, or 8 and 1, 1, which is not possible. So this cannot be even. Therefore, this has to be odd. So this is definitely odd here, which makes that odd there. Can this be 2 evens? Possibly. So this is odd, odd. Can this be even? Even, it could if it's 2, 4. Well, this could be 1, right? Technically, you could go out here, potentially. But then that would be 8. One of these is even, guaranteed. Can this be... Yes, it could be even if it goes that way. Right? Hmm. What happens if this is even? So if both of these are even, we have an even here, that would force all of these to be odd. So these would all be odd. This would have to be odd here because you can't have even there, so this would be odd and odd. This has to continue to be odd, so it has to be there. That's 5 odds there, so these are even. But then this doesn't work because this can only be part of this group here, which is size 3. So that fails. So this can't be even. Which means this is odd, and this must be even here. So we have 2 evens here and 1 odd here, which means the rest of this is odd. So we have all odds there. This is even, even. So this is not 5, which means this must be 5 here. So we have 5 here and 3 there. So this is 5, that's 3. This must go to 7 or 9. This is 2 or 4 here. It's not going to be 8, because then it blocks off this from connecting to a region. So this is 2 or 4. If it's 4, that works, because then these would both be even. You'd have all odds there. You'd have even there. 2 evens. 1 even there. 1 odd. So this cannot be odd, because if this were odd, the problem is this, you have one odd here, two odds, two more odds here. That's 3. This would be odd, odd. That's 5, and this could not extend any further. So, but this would be then a region of group of size 2, which is not odd. So therefore, these must be even. We have an even here, an even here, 2 evens here. That means the remaining digits are all odd. Well, this then is size 2 as a region. We have 5 odds in box 6, so this must be even here. And oh, we do not connect that as a group. That fails. Where did I mess up? I messed up somewhere here. Rig. Oh, shoot. I don't know. Okay, so this here, this part is, the problem is the execution. I'm not sure where I'm screwing up. Let me think that through again. Okay, logic for odds versus evens. Can we have even here? It cannot be 8, because if we have 8 here, the 6 can only take care of 2 evens in row 1 when all of them need to be taken care of. They need to be in a group. So, cannot be 8. If we tried 6, you can't go that way because that's too small. If we try, you can't have all 6 go down because the problem is that you have 5 evens in a column. Oh, maybe. Interesting. So you could have 6 and 1. No, I don't think that works. Hold up. Okay. What happens if we... So 1, 2, 3, 4, 5, 6. You can't have 1, 2, 3, 4, 5, 6 there. But maybe you can do this. This is red. I guess you could have... No, you can't. Okay, this is 3 blues. So, oh, you can't have a blue above the red. You have to have red above the red. Okay, so that does not work. So then you can't have that way because then this has to be both odds. And therefore this grouping would be size 2. Well, maybe that does work. Obviously, you can't go all the way here. That's size 7. So you would have red here. This is red. This would be all red here. You'd have to have all 5 here. Would you? Actually, maybe not. That is potentially possible. No. Okay, you have 5 evens. Yes. Okay, so that's the problem there. Okay, right. So again, you cannot have an even on the edges because of that. If we try to have even here, it cannot be part of 8 because we don't have the other evens all taken care of in row 1 then, if that's the case. And it can't go that way because then it would block the odd digit here from being part of a group. So it cannot do that. Therefore, it could be 6 potentially, But we can't reach 6 if we go that way, so you can't have you can't reach that way being 6. You can't go around because then the problem is this forms a set of 2 digits, which is an even sum. So this would be part of a group 2, and that's 5 evens in column 1. So yes, this has to be odd. And this must be odd, which makes that even here and even here. So one of these is 6. We tried just going straight down. Obviously, that doesn't work. Because it's 5 evens in a column. So one of them has to go like this. And if we try doing this, the problem is there are 5 evens in column 7 then in that case. So that's why that doesn't work. So this must be going down that way. That's all evens. That's 6 then. We have to take care of the other evens in row 1, so they have to be here. Otherwise, we'd be blocking a cell from having a group. So these are all red because we have 4 evens in row 1. These have to be, one of these is odd, the other one has to be odd too, to add up to an even sum. So again, so we have 4 evens here, that makes this all odd. We have 5 odds here, so that makes this all evens. We have 5 odds in box 4, which makes that even. This is opposite of odd, so this is even, and therefore we have 4 evens in column 2, so this is odd and odd. This must add up to, this can't be 5, so this can't be 3. This is 6, because that's the size of its region, because every cell must be part of a region except for the ones that we showed. This is size 1, so this cannot be 1 here, no 7 there. So this is a size, this is one grouping, region. This is part of one grouping from 7 or 9. This is part of one grouping from 5, 7, or 9. So this is guaranteed. Okay, so the question is, can we have blue, blue here, or blue? I think we showed that we can't really have blue, blue in either of these spots, right? If this is blue, blue, one of these is blue, which means the rest is all red. That guarantees a blue here. There's a blue there. Because one of these is blue, we have 4 reds here, one other red here, so this must be blue. So how do we have red? Red cannot go here because then that blocks this blue from the region. So red would have to go that way to connect. Therefore, this would be all blue, but that would be size 3 as a group, which is not allowed. So that's why this can't be blue. So this is red. What about blue here? If we have blue here, we have 4 blues here. That forces all of these to be... Oh. That works. How did I get that this was red? I don't know. I think, yeah, we have to... Oh. If this is blue, one of these two is blue. That means all of these are red. That kind of does work. I don't know how I got... How did I reach a contradiction? One of these is blue, one of these is red. I don't know. So what happens if this is red? If this is red, then this has to be blue. We have a red here. We have a guaranteed red here. It cannot be 2 reds here, because then that would be 5 reds, and then these would have to be blue, and then this would be a group of 2, which have to be odd, which is not allowed. So then if this is red, that means this has to be blue. We have 4 blues in column 8, so these are red. That's 5 reds in this box. So this is blue, that's blue. This is size 2. Since this is blue, this has to be red. And we'd have 2 evens here. So therefore, the rest of this would have to be odd. And this is a contradiction because this is grouping. So therefore, that shows this cannot be red, which means this does have to be blue here. Interesting. So this is 2 blue. We have blue here, so that guarantees these are all red. So this is at least size 3, because it can't be 1, because then this doesn't have a group. So these are all the same group. This is 2 or 4. Can it be 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Because if it goes this way and connects 8 here, the problem is it can't have more than 4 digits in this box as blue. And it would have to connect that way. So this is 2 or 4. This is red. Yeah, okay. I don't know why I naturally assumed that this had to be red. Okay, that was weird. So that was the problem there. If we go blue here, that means one of these is blue. This would have to be red. This would have to be red. Technically, it could still be 4. Because it could be 4. No, if it goes 4 that way, that would be too small. This would not connect to a circle. So this has to be 2, which means these have to be both red. Only one you could connect that way. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. So, oh, that's a problem. So if we try to connect this, the problem is this blue cannot connect to this because then it would be size 3. If we try to connect this, this would be too large for size 8. Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9 at minimum. So this cannot be blue then because of that. So this can't be blue. It's definitely red. So even if we connect here, we have to connect down to there. You can't go straight down for 8. Because then that would be 5 blues in a column. So we have to turn somewhere and then go down. And that's 1, 2, 3. So this cannot be blue. Because if this were blue, that'd be 1, 2, 3, 4, 5, 6, 7, 8. But then we have 5 evens in a column. So then this has to be red, which forces this to be blue. This cannot is either blue, blue, in which case this has to be blue, or I guess this could no. One of these is red, the other one is blue. If this is red, that means this would be blue. Okay, so this is definitely grouping here. And we have to turn 1 because we can't go straight down. So this can't be the 8. I think this has to be the 8. It can't get to here. It cannot go back here. That's too many. So yeah, this has to be 8. So this is blue and blue, which makes this red and red. So this has to connect to another red, either going that way or coming down if this is a 1. So this is 8. Could do something like that, potentially, or something like that. We don't know. It could do even something like that. Okay. This has to be 7 or 9. I guess it could technically be 1. Okay. We have 1 blue here, 1 red here. Can this be odd? Let's try. If this is odd, then it cannot be 4 going that way. It has to connect that way. So this must be 4 going there. So that's 1, 2, 3, 4. This is size 1, 2, 3, 4, 5, 6, 7. So this would be size 4. We'd have to have 2 evens there. So this would be 2. And then the problem is this would be size an even 2 odd cells of size 2. So this cannot be odd here. This must be even. So we have 4 evens. We cannot go that way as an even because then the problem is this doesn't have a grouping with a circle. So this has to be blue here, which means this is red going that way to connect. This is 2, 4 as a pair. We have 1, 2, 3, 4, 5, 6, 7. These have to both be odd. So 1, 2, 3, 4, 5, 6, 7. We have to connect with the blues, so that's connecting there. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. But 2 odds is going to add up to an even sum, so this we need a 10th one, which makes that blue, which makes that red. So this is size 7, which makes this 3 and 5. So that's grouping, that's grouping, that's grouping. And this has to be 1, 9 as a pair. 2, 4 as a pair, obviously. This is grouping there. 1, 2, 3, 4, 5. These are all part of the same grouping. It's just blocking whichever ones are these. Okay, this is 2 and 4. That means the rest of the box is all red because we have 4 evens there. This is 6 or 8 as a pair, which forces this to be 2 and 4 as a pair. Remaining. This is odd, so this must be even here. This could technically be... Okay, we have 5 odds in column 7, so the rest are all even. Okay. So this is not counted. This is at least 2. This cannot be even, because if these are both even, if this is even, both of these need to be even, and we have 5 evens in box 9. So these are both odd, which forces this to be even. So this is not counted as a group. This is at least 3. This is 3 odds there. These are 4 evens, so that eliminates evens in the rest of the column. So these are odd, which means we have 5 odds in box 5, which means the rest are even. We have 5 odds in column 4, so the rest are even there. Interesting. This must be part of an even set, so it has to be here. And that's 4 evens in column 6, so these must be odd. Okay. So this is size 4 as a region, this is size 4 as a region, this is size 5 as a region. As a group here. So this is a grouping. This is a grouping. These must add up to 1, 2, 3, 4, 5, 6, 7, 8. So it's 3, 5 or 1, 7 as a pair. This can't be 1, so this could be 7 and 1 that way. These add up to 6 as a pair. So this is a 1, 5 pair, which eliminates 1 and 5 in the rest of the column. So this can't be 1. That's 9, which makes that 1 there. So this is a group there. And then this is a size 9 group there. Maybe I should make it... maybe I should make the red not red. We'll make it green. So we can see the actual groupings. This is 1, 5 as a pair. Okay. This is definitely boundary there, and then one of these is with the one of them. Okay. Let's see. This is 2, 4, and 6 here, remaining in column. So one of these is guaranteed to be 6 there. We have 2, 4, and 8 here, so one of these is guaranteed 8. 6 can't be here. 6 is one of these two. One cannot be here, cannot be here. This is either 1, 7 or 3, 5. We have 2, 6, 8 here, 2, 6, 8 here, 2, 6, 8 here. This is odd, 3, 5, 7, 9. 5, 7, 9, 3, 5, 7, 9. 2 and 4 are consecutive with 1, 3, and 5. This is 2, 4, and 6 here. So we have a guaranteed 6 here. This is 4, 6, 2, 2, 4, and 8 here, with a guaranteed 8 in one of those two. No 4 here because of 4 in the column. This can't be 6 because of 6 in the row. 2 is consecutive with 3. 8 is consecutive with 7 or 9, so this can't be 5. This has to be 2, 6, or 8. Where is 4 in row 9? Cannot be here because of 4 in the boxes, so 4 has to be here. That eliminates 4 in the rest of the column. Where's 5 in column 2? Can't be here because of 5 in the boxes, so 5 has to be there. That's only consecutive with 4 or 6. Remaining digits here are 2, 8 as a pair, which eliminates 2 and 8 in the rest of the row, so this can't be 2 or 8. It's 6, which makes this not 6. That's 2. That makes that 8. So there's no 8 here. It's 2, 6 as a pair, which eliminates 2 and 6 in the rest of the box, so this can't be 2. It's 8, which is only consecutive with 7 or 9. Remaining digit in even digit in row 7 is a 2. So 2 eliminates 2 here, so that's 4. No 2 or 4 here. It's 6. 2 eliminates 2 here, so that's 8, which makes this 4. 8 eliminates 8 here, so it's 2 and 8. That leaves this as 7 and 9 again. And this has to be 3, 7, and 9. 3 can't be here because of 3 in the column. We have a 7, 9 pair in box 7, which eliminates 7, 9 in the rest of the box, so this can't be 7 or 9. That's 3. 4 eliminates 4 being there, so that's 6. That eliminates 6 from being there, and 6 from being here. 4 eliminates 4 here, so that's 2. This can't be 2 or 4, it's 6. 2 eliminates 2 here. 4 eliminates 4 here, so that's 2. So no more 2 here. Where is the 2 in column 2? It has to be here, which is consecutive with 1 or 3. 4 is not consecutive with 1 here, so this is 3 or 5. 8 eliminates 8 here. This can't be 2 because of 2 in the row, so this is 6. That eliminates 6 here, so that's 2, which makes that 6. We have 4, 8 remaining in row 1 and column 6. This has to be 2, 4, or 8 here. 4 and 8 are consecutive with 3, 5, or 7, 9. Okay, remaining digits in column 4 are 1, 3, 5, and 9, with a 1 and the 9 guaranteed here. That means the rest, we have a 1, 5 pair here. That makes this 3, 7 as a pair. This can't be 7 because of 7 in the box. So that's 3, that's 7. 3 eliminates 3 here, so it's 5. This cannot be 5. It's 1, 3, 9 as a triplet, which eliminates 1, 3, 9 in the rest of the box. So this can't be 1, 3, 9. It's 5. This has to be 3, 7, and 9 here, which leaves this as a 1 here. Okay. 5 eliminates 5 from this cell there. 2, 4. Okay, we have 2, 4, 8. 6 eliminates 6 here, so this is 8. That eliminates 8 here, so it's 6. 8 eliminates 8 here, so it's 2 or 4. 2 can be next to 1 or 3. 4 can be next to 3 or 5. So this could be any of them. Remaining digits of column 3 are 1, 7, and 9. This can't be 1 because of 1 in the row. So where is the 1 in column 3? It must be here. That means this can't be 1. It's 3. This can't be 1 or 3. It's 9. This can't be 3 or 9. It's 7, which is not consecutive with 4. It's consecutive with 8. So that makes that 8, which makes that 4. 8 eliminates 8 here. So it's 2 and 4, which is only consecutive with 1, 3, or 5. 9 eliminates 9 in the rest of the column. That leaves us a 7, 9 here, because and where is the 1 in box 4? It has to be here. This can't be 3 or 5 because of 3 or 5 in the row. That leaves a 7, 9 pair in column 1. This can't be 7 because of 7 in the row, so this is 9. That's 7. 7 eliminates 7 here. We have a 7, 9 pair in row 6, which eliminates 7, 9 in the rest of the row. So this is 3, 5 as a pair. Blah, 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 blah. 1, 7, 9. 8 eliminates 8 here, so this is 4, which makes that 8. We have 7, 9 as a pair here. That eliminates 7, 9 in the rest of the column, so that leaves us just 3 and 5. We have a 1, 3, 5 triplet in row 2, which eliminates 1, and 5 eliminates 5 here, so this is 3, which makes this not 3, that's 5. Not 3 here, that's 1 and 3. This can't be 3 or 5, it's 1, which is not consecutive with 4, so this is 2, that's 4. 2 eliminates 2 here, so it's 4 and 2. So this is a size 2 region, this is size 4. That leaves this digit as a 9. Okay, remaining digits of row 7 are 3, 7, and 9. This can't be 7 or 9 because of 7, 9 in the column. So that makes that 3. That means this can't be 3, 5 as a pair, adding up to 8. It must be 1 and 7. 3 eliminates 3 here, so it's 5 and 3. This is size 7 as a region. This is size 1 as a region. And 1 eliminates 1 here, so that's 5, which makes that 1. So this is size 1 as a region, and this is size 5 as a region. This can't be 3 or 7. It has to be 9. That eliminates 3 and 9 here. It's 7. 7 eliminates 7 here, so it's 9, which makes this 7, which makes that 9, which makes that 7. That makes that 9, which makes that 7. This can't be 7 or 9. It's 3. This can't be 3 or 7. It's 9, which leaves this as a 5. And that's the solution. Actually, I don't think it was that bad. I don't think it was very hard. It took a while to figure out the logic behind this, though, so that was a little bit difficult. But I don't think it was that difficult once you sort of understood the logic. Getting to that point was difficult. I don't know. I feel like once you understand the trick, it becomes relatively easy. I don't know. That's why I just feel like this isn't necessarily very hard. I would definitely still classify it as hard, but very hard seems a little bit. I don't know. I think I would classify this as hard. The logic wasn't too hard to figure out eventually. It took a while. I will agree with that. But if you think about it logically for enough amount of time, it makes a lot of sense how this is going to work, right? So I think I would classify this as hard, but that's just me. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.